Hi everyone, this is Saelyne. Today I'll be presenting our paper VideoMix, Aggregating How-to Videos for Task-Oriented Learning. This work was done in collaboration with Anne, Juho, and Ding. How-to videos are a popular source for task learning. People learn new skills such as cooking, knitting, or using Photoshop through videos, as they provide detailed and step-by-step workflows. When learning a task, people typically start with understanding the procedure of the task and then applying it in their specific context through execution. In the first phase, people gather and process information to develop an understanding, and they often do so by watching or skimming multiple videos. Watching multiple videos on a task can significantly enhance understanding of the task, since it offers diverse perspectives and insights. By watching multiple videos, learners can learn about different methods, tips, or techniques. However, watching multiple videos poses challenges. Most video platforms present videos independently in a linear format, which isn't ideal for task learning. Unlike entertainment videos, how-to videos require structured navigation and connections between videos. But processing large amounts of unorganized information is time-consuming and overwhelming. To address this, we first conducted a formative study with 12 participants to gain insights into how users learn new tasks through multiple how-to videos, and to understand the specific information they seek across these videos. To begin, we asked participants a few questions about their current practices on learning from how-to videos. Next, participants were asked to select the topic or task they wanted to learn, and once the task was chosen, we conducted a think-aloud observation study on how they learn with videos. These are the findings. All participants mentioned that when learning a task, they first start by watching videos to form a mental map before following the task. In this process, they seek to understand the materials, processes, and techniques involved. To watch videos, participants begin their video search with broad and general queries, which often yield a large number of videos. They would open the videos one by one or in separate tabs at once to watch. There were 4 key aspects that the participants primarily looked for from watching multiple videos. First one is outcomes, to understand the possible results of the task and decide which outcome they prefer. Second one is requirements, to identify the necessary tools or materials and check whether certain tools are commonly used across videos. Third one is approaches and methods, to explore alternative approaches presented by various instructors and find the method that best suits their needs. The last one is details, to gather additional insights such as tips or know-hows shared by different instructors. While participants found that watching multiple videos to be very beneficial to their learning, they also noted that the current process for using multiple videos is time-consuming and mentally demanding. The search queries returned a large number of videos that weren't organized in a structured way, and participants found it difficult to skim videos and spend a significant amount of time watching each video. Also, there was no easy way to compare and consolidate information across videos. Based on the findings, we present VideoMix, a system that helps users gain a holistic understanding of a task by aggregating and organizing information extracted from multiple videos on the task. Here is a detailed walkthrough. Let's say the user wants to learn how to build a desk. After selecting a task, VideoMix provides information extracted from dozens of videos. First, it presents video search results categorized by outcome types. Once the user selects an outcome type, they see 3 approaches: standard, the most common method; simple, the one with the fewest steps; and complex, the one with the most steps. Let's say the user chooses the standard approach for a modern and sleek design. VideoMix displays the required materials, ingredients, and tools, with the colors representing its frequency. Below, users can see a step-by-step breakdown of the chosen approach with brief descriptions for each step. Clicking on a step opens its details page. Here, users can explore different methods to complete the step. Selecting a method brings up video snippets relevant to that method. Users can easily switch between videos for the selecting method, with the corresponding time frame playing automatically. Users can also see tips and notes extracted from the videos. VideoMix organizes information from multiple how-to videos using a vision language model-based pipeline. Given a set of videos on the same task, for example, building a desk, it first identifies the different types of outcomes of the task through visual frames and narration of the videos. Then, for each outcome type, VideoMix determines standard, simple, and complex approaches to achieve the desired result from the videos that correspond to that outcome type. Until this process, videos are clustered into different sets. Next, once a video set is determined that follows each approach, VideoMix identifies parts of videos that correspond to each step in the approach. For each step, it then identifies different methods employed in the videos, along with additional details such as tips and notes for each method. In this process, video segments are clustered into different sets. To identify the outcome types existing in hundreds of videos, we leverage the narration and visual frames of the videos. We first prompt GPT to extract narration that is about describing outcomes and select the visual frames corresponding to that narration segments. Our pipeline then generates the detailed descriptions of the outcome frames and cluster the descriptions. To identify possible sequences of steps that may vary across different videos, we introduce a dynamic approach identification module. Our DAI module first starts by extracting step information from the first video using GPT, and then the step taxonomy is refined iteratively by comparing it with subsequent videos. Once the step taxonomy is finalized, it is applied to all videos to align relevant steps to corresponding video segments of each video. Finally, it identifies standard, simple, and complex approaches based on the step counts and video coverage. The standard approach is the most commonly used sequence of steps across videos, whereas the simplest approach involves the fewest steps and the most complex approach involves the most steps. Lastly, we prompt GPT to identify different variations in the methods and extract useful tips for key information for each method. Detailed prompts used can be found in the appendix in the paper. We evaluated our DAI module, which is the main technical component to detect step and approaches. Our hypothesis is that the pipeline-generated step taxonomy will provide as accurate step information and will better capture the diversity and variation within a task compared to predefined taxonomies. We chose 6 physical tasks from the How to 100 million dataset and obtained human annotated predefined step taxonomy from existing datasets. We recruited 24 external evaluators who are familiar with the selected task and assigned 4 evaluators to each of the 6 tasks. The evaluation focused on 2 main criteria, which are accuracy and coverage. For accuracy, evaluators rated the step information based on its relevancy, logical flow, and completeness using a 7-point Likert scale. For coverage, evaluators answered the question, how much does the sequence represent or cover all the possible ways to achieve the task, on a scale of 0 to 10. Results of the technical evaluation of our DAI module show that our pipeline maintained the step accuracy without showing any statistically significant difference, while capturing a significantly more diverse range of possible approaches. We then conducted a within subjects user study to evaluate VideoMix against a baseline YouTube-like system. We recruited 12 users who regularly watch how-to videos and often watch multiple videos to learn a specific task. For the study, we selected 4 tasks from the How to 100 million dataset, ranging from building a desk, building a bookshelf, making chicken cacciatore, to making jambalaya. For the within subject study, we randomly selected 2 tasks for each participant, one for VideoMix and the other for a baseline system. The order of the systems were counterbalanced. Here's the results. Participants were given 15 to 20 minutes to learn about the task. VideoMix presented information from an average of 77.8 videos per task, while participants watched only 2.6 videos on average using the baseline system within the given study time. Participants reported a significantly better understanding of the task when using VideoMix compared to the baseline. In particular, VideoMix improved perceived learning performance and efficiency and found it more useful for understanding tasks compared to the baseline, while not showing statistically significant differences in mental demand, effort, or frustration. First, VideoMix enhanced overall understanding of the task. P2 said, with VideoMix, he could see the overall process and get a general understanding immediately, which would have taken a long time to find on YouTube, where videos are scattered. Next, it also provided tailored learning experiences. P3 said it was helpful to see different methods to complete a step so that they can choose specific methods based on the tools they have. Lastly, it also helped specific knowledge acquisition of tasks. P8 said she saw certain ingredients were used across all standard approaches of different outcome types and learned that they are the key ingredients. Overall, they found the information provided by VideoMix to be helpful in gaining a better understanding of the task. So, as I introduced in the beginning, VideoMix is designed for the first phase of task learning, which is task understanding. However, participants highlighted several benefits of VideoMix in task following as well. They mentioned that it allows users to choose their preferred approach, which could be handy when following the task. And the mixed media format with text and the segmented steps enable users to quickly revisit specific parts and makes following easier. However, a few participants mentioned the discontinuous nature of the segmented videos throughout the steps, which could hinder the learning process. To better support the full learning cycle, it is important to support the tracking of a cohesive procedure within a single video to ensure the consistency and flow. Features like real-time Q&A or interactive search could also address the user's more specific needs as they progress through the task. Instead of treating videos as the primary object, VideoMix treats the task itself as the first-class object. To do so, we designed a multi-video system with multiple video segments structured around it. While splitting content by step made it easier to digest for users, we also found that they could feel a sense of discontinuity between segments, sometimes lack the broader context. To address this, a multi-video interface should ensure that enough context is provided and consider strategies to maintain continuity, such as using a common voiceover, visual connectors, or a consistent theme across videos. One of the limitations of our system is its reliance on the quality and the quantity of the source videos. Since the system compiles content from various videos, the clarity of the presenter's instructions significantly affects its performance. Clear and well-structured narration is essential for VideoMix to function effectively. In terms of quantity, the system may not provide a comprehensive overview when only a limited number of videos are available. In such cases, we could consider expanding the search query to include more detailed terms or incorporating additional tutorial resources to supplement the content. Lastly, VideoMix has primarily been tested on tasks involving the creation of physical objects. Other types of tasks, such as digital tasks like Photoshop editing or guitar tutorials, may introduce new challenges, and it will be necessary to understand their unique design considerations. Nevertheless, beyond how-to videos, there is potential for the concept of VideoMix to be applied to other domains, such as organizing interview videos by specific questions or themes, or educational videos by subtopics, providing a more structured learning path in a range of perspectives. In summary, I presented VideoMix, a system that helps users gain a comprehensive understanding of how-to tasks by aggregating information from multiple tutorial videos. Our work highlights the potential of a task-oriented and multi-video approach to support users in task learning, providing an important step forward in improving how people learn from tutorials. Thank you for listening, and please feel free to send me an email for any questions or discussions. I'll be happy to chat.